Alright, now let's take f of x is equal to x cubed. Now, this is actually pretty simple to do algebraically. If we use a table, well, it's going to be a combination of numerical and algebraic approaches. So we're going to basically make a table. But first off, what's my width? It's going to be 8 minus 0 over 4. Because remember, it's b minus a over n. You got to remember that, because if I would have said 3, it would give you different numbers. But this one's nice. It's 8 over 4, which is 2. So I'm making it nice and neat for you right now, and just know that sometimes it's not going to be nice and neat. So what I'm going to do is I'm going to create a table. And I'm going to put in this table 0. I'm going to skip a section, put a 2. Why would I go to 2, from 0 to 2? Yeah, that's where my next subdivision point would be. Now, why do you think I'm skipping one? For the midpoint, well, I'll put it right there anyway. And I'll put mid, like right there, just so I know. And because sometimes the midpoint makes things weird. If you know if you're going to use the left endpoint or the right endpoint, I mean, it's going to make a difference. But yeah, you'll be given that, yeah. All right, so we'll just do 3. Is 3 a midpoint or an endpoint? All right, so I'll put an M there. There's 4. 5's a midpoint, so I'll put an M there. 6. 7's a midpoint, isn't it? And then 8. Now, I want f of x. What's 0 cubed? 0. What's 1 cubed? 2 cubed is 8. 3 cubed. You're right. 4 cubed. 5 cubed. 6 cubed. 7 cubed. 8 cubed. Now, these are my endpoints. I'll just move this over just a little bit. We've already done the hard work, believe it or not. Now, which one, if we looked at the first interval from 0 to 2, which one is the left endpoint? 0. So if you would do that, you would say, all right, if I'm going to use the left endpoint, I'm going to use 0, I'm going to use 2, I'm going to use 4, I'm going to use 6. Do we use 8 as one of our rectangles, that height? Not with the left endpoint. So we're going to use all but the last one. If we go with the right, we're going to start at the last one, and we're going to use all but the first one. And then the midpoints are, we check them off in the middle there. So if I want to get you'll see it when we deal with that. Just the left approximation. What numbers am I going to add together? I'm going to take the 0, the 8, the 64, and the 216. So add those together. 0 plus 8 plus 64 plus 216. That's 288. Now with the right approximation, it's going to be 8 plus 64 plus 216 plus 512. So 8 plus 64 plus 216 plus 512. And that's equal to 800. Now, the left and the right pretty much give us the bounds of what the area under the curve is going to be. The area is probably not going to be less. It's probably, well, it's going to be bigger than 288, and it's going to be less than 800. So we just don't know exactly which one is going to be which. Now, let's do the midpoint and use all the values for the midpoint. 1, 27, 125, and 343. And so we get 496. And since they're areas, unit squared, unit squared, unit squared. Now this is, like I said, this is how you would approach a problem like this algebraically. Well, a combination of numeric and algebraic. If you want to be purely algebraic, you would say this. You want to do the summation of what's the width? 2 times x cubed and then you'd want to figure out what those would end up being, and that would be a lot more challenging. So this we'd like to kind of just pass on by, and we say, all right, well, this is what we want to do. And if you make the chart, figure out the subdivisions, put those in, put the endpoints of your intervals in, and then put your midpoints in there, and then just check off which ones you want, you'll be able to actually calculate your areas, your left, right, or midpoint approximation really, really easily at that point. Now, this is what's going on, and this is where we're headed. it's the summation of I equals 1 to n of this is one way to think about it. Another way to think about it is the summation from I equals 1 to n of the width times f of x sub I. Where, depending on if it's the left or the right, and eventually what we're going to do is, let me just ask you this, are any of these any good as far as approximations go? If we want to get, I chose 4 rectangles here. For this graph. And what could I do to make that choice better? What could I do to minimize this extra bit right here? So instead of breaking it into 4 rectangles, do you think 10 rectangles would give me a better approximation? What about 100 rectangles? What about 1,000,000 rectangles? Eventually, what we're going to get at is when we're looking for the area under a curve, like from here to here, we want to look at a straight line, just a line right there, where if I blow this up, it's a rectangle. Where this is delta x, and this is f of x sub I. And if I can put as many rectangles into this as I possibly can, all of a sudden I have my area. So if I can just keep drawing lines right next to each other, and if I can make it into an infinite number of just straight lines like this that are infinitely close to each other, and then eventually it's like a deck of cards. One card's super thin, but you put 52 together, it's about an inch thick. You put an infinite number of lines together, and all of a sudden you have the area under the curve. What this summation starts becoming is this. Where this is the area of the rectangle. That's the height, that's your width. This is where we're headed. But first we have to talk about approximation and using the left, right, and the midpoint approximations.